Good morning from Toronto, Canada. My name is Armin Moltke, and I would like to welcome you all to another live Quanser user webinar. In this webinar series, we highlight the works of academics from around the world who use Quanser solutions and technologies as part of their research. Today, we are beyond honored to have a great friend of Quanser, an eminent researcher in the field of autonomous vehicles, Professor Yumin Zhang from Concordia University, to discuss his research on autonomous and fault-tolerant control. I'd like to take a moment to introduce today's esteemed guest speaker. Dr. Yumin Zhang is currently a professor at the Department of Mechanical, Industrial, and Aerospace Engineering at Concordia University in Canada. His main research interests are in the areas of condition monitoring, health management, fault-tolerant control systems, as well as cooperative guidance, navigation, and control of unmanned vehicles. He's particularly interested in their application to monitoring forest fires, pipelines, power lines, wind farms, solar panel arrays, and natural disasters. He has published 8 books and, get this, over 550 journal and conference papers. His research work on unmanned systems with applications to forest fire detection and autonomous transportation has been featured on Canadian national TV, including CTV News and Radio-Canada International. Dr. Zhang is a fellow of the Canadian Society of Mechanical Engineering, a senior member of AIAA and IEEE. He is currently the president of the International Society of Intelligent Unmanned Systems, as well as serving on the executive committee of the International Conference on Unmanned Aircraft Systems. He has held various editorial positions with numerous journals, including the Journal of Intelligent and Robotic Systems, as well as the IEEE Transactions on Neural Network and Learning Systems. Professor Zhang, welcome. The audience is all yours.
Okay, thank you very much, Alan, for your nice introduction, and also thank you also very much for the opportunity. Oh, sorry, I need to go to the first page. Yeah, thanks to the opportunity for this webinar to share our work with also the cutting edge of platform supported by Quanser for many years since I joined to Concordia in beginning of the 2007. So idea is actually today strap to show what we have done through this cutting edge platform for helping or aiding the teaching and the research work carried out our group, and also really appreciate for the great support from the Quanser team for many years of support. So this is actually the outline for my talk. So which actually just introduce some platform available and also fully supported by Quanser for many years of support. And also basically we use this for the teaching for this flight control system course teaching, and also the fault diagnosis and the fault control system course teaching, which is the graduate level. So then I just go through a little bit that is what are the challenges and the new development towards the smarter and the safer and the more reliable and the resilient unmanned system and the applications, as I mentioned earlier. We basically went the research for the first fire monitoring. I use multiple unmanned systems, including on the air, on the ground, on the surface of water, and also on the space of satellites. Then, if someone actually you didn't work on this photo control system, then also just give a brief introduction for what we mean photo control system. Also, that autonomous system, abbreviation as AC. Then there's also considering when we have multiple unmanned system, even including different type of unmanned system. So this is what we mean for so-called FTCC, Fault-Tolerant Cooperative Control. So then just introduce what we have carried out all this research works for testing the different strategies in the platform available. So in our lab, actually supported us mainly from Quanser. So here actually it's a review for Montreal, just in case you have not got a chance to come to Montreal. Welcome to you come to Concordia, come to Montreal. So this actually is a building office here located in the UAV building. We call the UAV building. So, but overall, this one slide just show the research works highlighted with that the research field and some research project. So particularly what I present here also, because this is also the research work and the platform. Initially, because one of the project called NSERC Strategic Grant, which was actually starting from 2007. So we start with collaboration with Quanser. So for developing this different unmanned system in general, UGVs in general. So for using this the different applications for solving that the safety issues and the fault tolerance issues with the publications and like also I mentioned earlier for this medium of interviews with the city videos or several public mediums. And so yeah, I can see, if you can see this on the right side, on that side actually I have some sun here. So and so as you can see, we have all this the platform on the right hand side. So which actually we use this for our research, for aiding our research. Then we have also published, if you are interested for more details, because the time limitation, probably I just go over quickly with all maybe videos to show how we can use this platform for aiding our research. But if you're interested in more particular development and the algorithms, so you can come to my publication list website, as you can see on the bottom of this slide. So these slides actually also show some review papers or survey papers, which actually summarize different aspects with also the applications for the first fire monitoring and for the power line monitoring, and and also talk to that fault-tolerant control or FTCC and the fault-tolerant cooperative control. As you can see, the first review paper, which is online available freely, can be downloaded, which basically summarizes the overall development in the field worldwide for what we call this fault-tolerant cooperative control. It is still a relatively new subject, still have more work to do on this. We also publish some books with the different field applications. And so I just show you quickly. So here also summarize the research in our group. So basically we mainly work on the unmanned system in general, on the space, on the air, on the land, on the surface of water. But also we, second subject, we also work on this renewable energies for the smart grids. So also try to look at that opportunity for the smart city applications. So then also use this AI based for monitoring, diagnosis, prognosis with different applications. Also even work on this medical, human and animals health monitoring works. So all this work actually because also in addition, thanks to the Quanser's great support, long-term support. So also because also all the student researchers, social postdocs. So all this works thanks to all their contributions. Anyway, so this here I just try to show some pictures and also some videos for what our plan for. So I always call this as a toys, but the most important one, as you can see, we have this quadruped helicopters in the middle one. I think you all know that it's called QBall. So now we have the second generation of the QDrone. So early state of this different, and like you can see, how about QBot. So, and also we have all this since the birth of this QBall and also QBot and also QGV. And now we have also this, all this, the QDrones, a different platform in our research lab, including this micropilot MP2128 autopilot. So then we try to make use of all this cutting edge platform. So try to help us for doing cutting edge research, hopefully. So this, as you can see here, is the latest one from Quanser called QCar. So we have two, thanks to Quanser, for us to be able to use this cutting edge platform for doing research currently. So as you can see here is also our outdoor test bed, which is coming from the DJI M300 with onboard cameras, which include the color cameras, infrared cameras. So we are trying to use this for the first fire monitoring applications. But here, just for the quick view, I'll show some videos what we have done here recently. So then just have a rough view for how we use this cutting edge platform for helping us to do the research on the applications for the policy fire monitoring. As you can see, this upper one, we have this QBall, and also the QDrone, and also QCar. So this is actually the application with that M300, Matrix 300, with onboard sensor we are hanging out that mimic the fire detections, which include both the motion control and also the imaging processing by using the latest deep learning method and also the AI technique for helping us to achieve that goal. So you can see this testing scenarios. So we use all this technical platform. So as you can see, we have this 3 QBalls, and on the floor you can also see that UGV, and so there are some different platforms available. So we also use this currently for the leader follower multiple vehicle for this formation control applications in general. And so just to show quickly for these scenarios that I showed we have done. But anyway, if you're interested in more testing scenarios, you can come to this website, which is we call the NAV Lab for the Concordia, actually. So Network Autonomous Vehicle Laboratory in Concordia. Actually, we have all these videos uploaded since more than 2 years, 10 years ago. As you can see, the first one we uploaded more than 10 years ago with all this test platform initially from QBot. So then try to mimic all this, implement different strategies for implementation for this fault-tolerant control algorithm behind. So there are more videos. So once we have done videos, actually upload on this YouTube channels. If you're interested, so you can watch all these videos. Probably I can not have time to show all these videos here. So you can also do some. So maybe I can show these videos here. As you can see, yeah. So probably you cannot hear the voice, but anyway, so yeah.
Ways to detect forest fires.
It is reported by CTV News. So for our forest fire monitoring application.
Batteries. But one these aircrafts are missing are pilots. The visual camera PhD mechanical engineering student Adam Hosing says this may be the key to getting on the planet's forest fire situation. Human beings wouldn't have to keep an eye out for forest fires.
Yeah, probably you cannot hear the voice due to the technical difficulties. Anyway, you can watch this if you are interested on the website.
The point where we need to address it. Forest fires cause millions of dollars in damage and can lead to the loss of not just homes and landscapes, but lives as well. Professor Unmanned says drones are the best way to combat this global crisis.
If we can use drones, fly on the air 24 hours, 7 days a week, continuously and observe any potential fires, even in the local stage, they will avoid this kind of big disaster. As long as we have a problem, those views, they all can fly longer.
Jan and 26 members of his class are working hard on image processing and motion control for many types of drones, each with its own advantage.
We have 80 propellers. The purpose is that 80 propellers on the top and the bottom, then basically try to improve the safety of the drones.
Older methods of detecting fires, including having people in towers or on foot, can result in errors. People may point the exact location of a fire. Drones don't make those kinds of mistakes. Drones can also be used to monitor pipelines and power lines, or for search and rescue. Hossein says his work with drones and image processing comes with unique sets of difficulties.
Fire isn't like other objects that you can easily detect. It doesn't have a fixed shape. It doesn't have a fixed size. It can be small. Even the color of flame, it changes a lot. One of the bigger challenges is detecting smoke, because smoke can be white, it can be black, it can, if it's far away, it can blend into the background. Smoke may be the first signature that we see about a fire. The flame could be hidden up in the forest.
Climate change is making this research more important every year.
Scientists say over and over again, because of climate change and everything, it's only going to increase. What I'm doing, it can save lives, it can help save the environment.
Scott Brooks, CTV News.
Okay, I just show this as an example, but I mean, as I mentioned earlier, so there are more videos, testing results available on this website. But also I want to show maybe this one, which is also use the latest QCar as the test bed for carrying out this autonomous control at this stage. So because of the pandemic, even we received this QCar, so the student have to do the experiment testing in his apartment. So they finally, so because this experiment testing result, also the algorithm implemented by use this cutting edge QCars. So finally, actually, we have one paper published in the I2B transactions on industry mechatronics. This electronics. So it is actually from what the information I can see. So it is the first one. So we make use of QCars for the testing scenarios. Then I published the paper to this one I2B transaction on these journals. So anyway, we are still trying to make more and better using of this cutting-edge autonomous cars from Quanser. So try to test in the different scenarios for the single QCar and for multiple QCars, so for the autonomous control, and hopefully also for that fault-tolerant control implementations. There are more videos available here, but due to time limitations, I will not show all this. So we still try to currently work on more for this more applications to be achieved based on this cutting-edge test bed or platform. Anyway, so I have more the slides you show all this. We also modify this from a portable helicopter to octocopter. So basically try to use this for the mimicking, so the simulation of the damages during the flight, then try to implement what we call fault-tolerant control algorithm behind. So that also the earlier one, we also have one CTV News interview at the university. But anyway, I maybe show this video because that also the point we use this for this teaching purpose, used for this university for the collect control system teaching, and also for this fault-tolerant control teaching.
This kind of weather helicopter for teaching purposes for flight control system course and fault-tolerant control system course. In this lab, we have two QBalls. We use it for research and we go through many scenarios and very deep theory for fault-tolerant control systems. Sometimes you like to evaluate some models. We like to fly with joystick and to see how the real system is.
This is my earlier stage of the smaller lab. So let me move to the larger lab.
Damage, like splitting of the propeller. Then we can get the information about this saturation of PWM signal to
and this is the QBall in my teaching lab.
You can see the plots blue line is the trajectory we gave to QBall, and the green line is the real position of the QBall, which tracks the trajectory. Most of the students, they see slides, they see the theory of flight, and they just hear some names like roll, pitch, and yaw. But when they come to the lab and they get familiar with the theory of control, they see something is moving, and all that knowledge, on paper or on computer now is going to be in real time. They get more ambitious, take more courses related to this area, and just to continue to work.
Okay, I just show this quickly for this videos made by the university, and also the CTV news interviews, earlier stage, and also the late one. But anyway, so due to the time limitation, I'll not go through more details. And so like you can see this all the platform we also try to develop it in the research lab with also publications. So as you can see, also we have this testing result by making use this earlier stage of this QBot and also this QBall. So for the testing scenarios, implementing the different strategies in terms of that what we call fault-tolerant control and the fault-tolerant cooperative control, and also with applications to the first of five application scenarios. But anyway, I just muted the voice so you can see the motions behind. So ideas we try to making use this cutting-edge platform for testing the different strategies in terms of overall motion control, and also towards different application in the indoor environment. Also try to mimic what if for the fire occurred, then we try to do the detection and continuous monitoring and even prediction for the future evaluation of this forest. So try to work on this for more application areas. So as you can see, also this is the first time we implement that the 3 QDrones in the lab. As you can see, also try to apply this second generation of QDrones is the first generation of QBots together with you can see the layout in the lab. So as you can see, there's someone actually sit behind. So actually from Quanser support Oliver, and so you see we also put the videos for, because that's the first time we testing this QDrones several 3 years ago. And so try to make use this for the research and for the teaching applications. But due to time limitation, I will not. I just stop here for these videos. Some videos it is available in the website. We also develop this our own for the fixed wing. Yeah, so from this scratch from beginning with this powerful gimbals, and try to do the outdoor flight testing in the nearby location for Montreal. So try to use that in general for the first of our monitoring applications. So that is just an overview for the platform available. Really appreciate for the great support from Quanser and also other companies. So the second part actually is related to the teaching. That actually the made by Quanser. It is, as you can see on the left, is our lab menu for this flight control system course. We call the MAC 480 for the undergraduate, and the MAC 6091. It is for graduate. So basically, we have both undergraduate and a graduate student for taking this also the challenge course. So I think until now we still probably use this flyable Fault-Tolerant helicopters, thanks to the Quanser strong support. Then we are able to let the student, undergraduate student particularly, making use the cutting-edge platform for understanding the concept of modeling and control analysis of this kind of aerial vehicles, particularly use the Quadrant helicopters during the 6th lab. So the lab will describe all the details of this including the vision system and the dynamics and the control strategies for controlling the QBalls. That actually, so what we have used since for 2010, is more than 10 years until now. So even also later also read one conference paper which is presented in the 2011 in the conference this related to the education and new learning technologies presented in Barcelona in Spain. So that if you're interested, they'll also have the paper available. Basically, just introduce the ideas and what we have used this cutting-edge platform for the courses of teaching, particularly for the undergraduate student. That's also why university interestingly put that record that professional videos for introduction of this applications for use cutting-edge platform, particular unmanned system to this courses teaching. Will actually which help a lot for the student to have good understanding for the concept to be covered in the course. So now actually I move to this more research aspect. So anyway, so that also just show the applications. This is more general in case you want to know a little the future applications, the challenges for using this unmanned system in general on the air, on the space, on the land, on the surface of water, or under the water. So how to use for the different applications for making this kind of unmanned system smarter, safer, more reliable, and more resilient. So with different applications. So we are actually trying to work on this with use this platform towards this autonomous and safe operations of all this different type of platform. So, and also, if you're interested, you also can see the papers were published. This is the paper published in 2015 in the Progress of Aerospace Science. So, which also have also sensor on the board information, because we also work on this with the companies for this application. And so all this I just go quickly, just for the views of whatever we call this unmanned system, UAVs or drones, and the UGVs for the different scenarios. So you see it for the autonomous cars. So there's a lot of more opportunities on the future commercialization also. So for the on the water, on the surface of water and the underwater, and you also can see our review paper published in the annual review control in 2016, which summarized the latest development for using this unmanned surface vehicle or USV with different applications and UUVs. So by the way, so we have this different type of unmanned system. What is the general? So for making good use or good control of this kind of different vehicles or unmanned system. So you generally, so if you look at from control point of view, we'll have 3 keywords: guidance, navigation, and control. No matter what kind of platform we have on the space, on the air, on the ground, and also on the water, and also the different applications. The keywords behind this 3 keywords. Even this actually talk about for the general normal operation conditions. Then what if during the operations, when the fault occurred in the actuators or sensors or some part of the system, then how to make the system safe and reliable for the as if the normal operations. This is actually the subject of what we call the fault-tolerant control. So we try to make the unmanned system in general smarter, safer, more reliable. This is more reliable basically in terms of the what if during the operations the physical faults occurred in the sensors, actuators, or some part of the components of the system. Then we try to make the system safe. So this is actually the subject for the fault-tolerant control. But more resilient, it is also really relevant new subject in terms of control aspect. So which basically consider due to this communications and internet connections, so wireless communications, then if unfortunately some cyber attack occurred, so how can we still guarantee the safety and also the security? It is a really relatively new subject. And how about this combination of the physical faults together with cyber attack to make the system, that's also the four keywords: smarter, safer, more reliable, more resilient. For the single vehicles, for the multiple vehicles, for different vehicles with that collaborations, it is still really challenging the current state of the research field for more works towards these different applications. Actually, generally, I mean, this is just a different application I want to show here. I just go very quickly with the different scenarios. I think we still have a lot of work, a lot of opportunities for carrying out the more advanced control strategies, even together with the imaging processing technologies for doing all these works. As these typical examples of forest fire monitoring applications, basically which including both for motion control and also the imaging processing. Then we can use this AI or deep learning method for both part, imaging processing part and the motion control part. So this, like you can see here, I try to summarize the challenge issues towards these applications. So sensor on board is one, and also the intelligence, and also from a research group aspect. So we work on this, what we call fault detection diagnosis, or abbreviations FTD, and this is fault-tolerant guidance, navigation, and control. And also we can simply see that is just a control issues, we simplify as FTC. So we have keywords of FTD, FTC, and for the multiple ones, so we have that called FTCC. So that also somewhere should deliver the ideas what I want to deliver from today's talk, related to the keywords of applications for this particular use for fire monitoring as applications. There also the fire detection, fire diagnosis, fire prognosis. What if we have this different type of unmanned system working together for providing faster and reliable, precise solutions? Then we have to solve that both issues for the motion control and also the detections in terms of fires, also with different other application monitoring for the power lines or whatever the nature disaster is actually. So this actually paper related to that first paper I mentioned for that review paper, so which will be published in the next issues of this Chinese Journal of Aeronautics. So basically just try to use this first fire monitoring applications as a background, then considering what if the fault occurred, physical fault occurrence, and the cyber attack occurred, then we still have a lot of work. Really, it's really the cutting edge research subject from my understanding. Anyway, so this actually just give the rough definitions of what we mean the fault-tolerant control application. But anyway, some videos I will not have time to show more. Probably you can watch it from the website I may point out earlier. So when we talk about this fault control system, basically it is a control system. So then the idea is we try to design such kind of controller we call the reliable controller, or now we call this as a passive fault controller, or if treated as a system, we call this as a passive fault control system to guarantee the safety and acceptable performance in the presence of different faults occurring in the actuators, in the sensors, and some subsystem in general. Then we try to achieve that requirements in terms of generally stability and performance in the presence of faults. Then we call this as a fault control system, but we have a way of this so-called passive, in the sense we just try to design one controller, cover all the situations, the normal situations and even fault situations, but it's a challenge. But in this situation, it's simple, but this probably can only handle the small level, small magnitude of fault. What if I have a severe fault situation? Then we have to add more functions, what we call here FTD part, for detection and diagnosis. Then together with the controller reconfiguration part, then we have to design such kind of control strategies we call active fault control. This active in a sense to detect, reconfigure the system in the active way, try to figure out what happened or fault occurred in the actuator sensor and the subsystem. Then we try to still maintain the stability and the performance. So now actually this also should extend it for what if the sub-attack occurred? It is still the very challenging subject for working on this field. And I maybe show these videos for some of you what we implement. One of the control strategies we call this as control reallocation. Try to also make use of the quadrant helicopter. So, but anyway, modify this with that octocopter. So with 8 propellers, then try to implement what we call this control reconfiguration strategies for handling the propeller damages during the flight. So yeah, maybe just go a little bit earlier. So the likely stage. Anyway, so probably I will not show more for this video, so due to time limitation. So you can watch that videos on the website. You see that scenario. So when we do not implement that FTC algorithm, then due to that the large amount of fault occurrence in the propeller, then we lost control of this helicopter. Then we implement even simple this FTC algorithm based on the control reallocation algorithm. Then finally we can stabilize this helicopter, then have a safe landing. Finally, you see that physical damage we may make during the flight. Then even we lost one of the propeller, then we still are able to maintain the stability, have the safe landing of this. So anyway, the concept behind is showed in this black diagram. If you're interested for the work, so you can see read the paper we published earlier. So you can also find that papers in my publication list. Anyway, so just go quickly. So yeah, this actually some the challenges I summarized in the earlier review paper we published in 2008. It is one of the actually who widely cited paper in that annual review control. So of course, because that the safety issues, fault-tolerance issues, one of the hard subject for doing the further development in terms of research and development toward the real applications of this unmanned system. So anyway, so there are still more challenging issues as I showed here. So, but due to the time limitation, I will not mention more details. But anyway, so we need to make use of hardware redundancies. Then together with that FTC algorithm, basically by making what we call the analytical redundancy, then implement in the passive or active way, then try to achieve that stabilities and good acceptable performance with also the online parameter estimation or system applications to find the post-failure model. All this actually some challenging work to do, but still, so it is possible. Like you can see what I showed here with different papers and also the current works are already done. Anyway, so this is just show quickly of what we have done. But this is the work we've done earlier with a fixed wing, even implement a simple scheduled PID for handling the rudder failures in the fixed wing airplanes, which is a models we actually combine with this simple plan, the autopilot. So for the implementation, so one of the earlier works actually. So now I just mention brief introduction for that multiple vehicles, what we call the FTCC. Previously, mainly focused on single ones, we call the FTC. For the multiple one, then the communication will naturally evolve. Then the most important, the navigation, coordinations, or this kind of strategy must be implemented in the multiple unmanned system as a whole. So we could have maybe the drones on the air, or the UGVs on the ground, or the USVs, and also together with the satellites. Then it is a little bit challenging work in general. But as we showed in this review paper, so basically, so there are still currently more work to do. Particularly for that, I mentioned earlier for the cyber attack, it is still need more works in general. So, so the overall concept or the ideas behind or principle behind for what we call the FTCC, it is still related to the two fundamental functions. similar like a single ones, but with different strategies, different program formulations, of course. Then we call the FTD and FTC. But overall, because we involve multiple vehicles, even different vehicles in terms of the physical faults, in the sensors, actuators, and also communication links, and also the cyber attacks, how we can still maintain the stability and also the good control of the multiple vehicles. It is still challenging work, and this is a view for that really paper. If you're interested, you can really download from this journal. So overall, we work on this different algorithm with different plan form. So with that subject I mentioned for the FDD, FTC, FTCC, with model-based method, with also neural net-based method for the linear models or nonlinear models, different control strategies. So for the different scenarios. So if you're interested, you can read from the papers published earlier. So here actually some videos actually I already showed as earlier work we have done, but currently we still try to use more of this platform for the testing of different scenarios in our work. But the more information you can find from these videos and also the publications in the website here as a show. So rest of the slides just to show quickly what our recent development for this quadruped helicopter implemented to the QDrones. So as you can see, this the strategy is implemented based on the disturbance observer-based strategies by using slide mode control with the observer to estimate the magnitude of the fault occurred in the quadruped helicopter, try to maintain the stability. This is still based on the simulation. So one of the work actually later we have to do the explanation because of the pandemic. So we also have challenges for going to the lab. So, but yeah, in the future we try to make more testing scenarios. So for testing the different strategies, as you can see, this use also the neural network for the implementation. At least to do the simulation first, then to do the experiment testing for validations in the second stage. But this work actually my PhD student graduate, he also got now as a associate professor in the university, you can see here, Northwest Polytechnic in China. So this is his experimental result. I use the QDrones together with QBall for implementing this tracking control with different scenarios, as you can see from this video. Yeah, this is a strategy for the path planning, and also try to have a static obstacle to achieve that obstacle avoidance trajectories for quick control of this field zone. Yeah, we have two. Yeah, with two to talk about the mimic that dynamics of that avoidance. Okay, due to time limitation, I just stop for that video show. So this one actually also with the collaboration also former the researcher associated with me. Now is Professor Xiang Yu. He's working as a professor in Beijing University for Aeronautics and Astronautics, BUA. So also uses QDrone for the fault-tolerant control implementations this cooperation with the well-known Professor Andrews in ETH, but the paper is still under review. So we submit to the several journals, still under review stage. So implement different fault-tolerant control strategies with the cutting-edge QDrone platform. Anyway, so that is some for the single one and the multiple ones. So we also work more on the multiple ones, but it's still in the simulation stage by testing the different strategies behind with leader follower strategies and with the distributed communication structures. So as you can see, we published some papers in the recent years in different like particular attribute transaction on neural network linear system, cybernetics, or the different journals. So with the different methodologies behind to mimic different scenarios, different constrained situations for the one leaders or multiple leaders with this different scenarios. Also for the oil refilling, this kind of applications. So like we have this kind of what we call the fault-tolerant containment control of multiple UAVs with this specified format. Anyway, so if you are interested, you can read all this from the paper. I have no time probably give the detailed explanation for what we implement for these different scenarios. Also try to use this for the first fire monitoring, smart safety, observations, or this scenario, which mainly based on Dr. Zhiquan Yu, his PhD thesis work, and so currently he's also working in the Nanjing University Aeronautics and Astronautics. So my student also work on this first fire monitoring applications. As you can see, also with this deep learning method for both motion control and also the imaging processing. We also just implement the different scenarios. As you can see, I have many videos here just so quickly, as you can see. So also mimic some simulation environments. Due to pandemic, my student also made this kind of indoor test scenarios for testing these different strategies for both imaging processing and the motion control with this 3D view and this simulation environment for the different applications they have. Yeah. So this latest one for this M300 testing we did recently for the real-time onboard detections with onboard computer, which we started on the M300. So you can see that real-time planning and also the detections for the smoke and also flames actually occur. But still, we still just do the preliminary testing with this latest platform available in Europe. As you can see, we have a color imaging and infrared camera with this detection algorithm implemented by using UNet. UNet. So anyway, I just stop here for more questions. Now, this actually result we use this on ground vehicles. Even we also have this scenarios with this the UGVs, also from Quanser, and also this probably not many research group have this platform. But the latest one is what I showed earlier for this QCar. So we have a different testing result earlier for all these different scenarios. Let me just show that videos quickly. So with the different test scenarios we implemented, but with of course the different algorithm in all this explanation implementation. This work actually from Professor Ali in Hunan University also uses QBall for doing the testing. So as you can see from this one, so this one we implemented in Concordia here. Yeah. For this QGVA, basically you also implement for different tracking, static, dynamic, stack avoidance, and also for what we mentioned earlier, for that FTCC algorithm behind. So with this different test bed for validation and testing different strategies. But here you see that it's a paper I mentioned earlier for the publication with even friction estimation for the autonomous vehicle applications and also the control parts. And we use the QCar for the implementation. So that is the paper I mentioned earlier for this TIE. It is available online, but not officially published in the paper format yet. So like also with different applications, different works for that is from the Jingdong platform, autonomous car applications. We also have the simulations for the different scenarios with multiple robots, mobile robots for all these different applications, as you can see here. And you can see that paper we published, which listed in the publication list with the different scenarios. So we also work on this spacecraft in general, but also focus on this actual faults with a different platform. But of course, we do not have that really real platform. It's so challenging. We have this hardware platform. But anyway, we also collaborate with the Canadian Space Agency some time ago with that formation of the two sides that the hardware is from the Canadian Space Agency for the FTD part of work for the formation scenarios. That is one of the earlier work. To work on the wind turbines, although we are focused on the unmanned system, but we also treat this multiple wind turbines and the solar panel is also part of the unmanned system in general for generation of the electricity. So we also work on this for the FTD, FTC, and the FTCC for the, of course, different algorithm by using even fuzzy logic for the implementation. Even also we use that FTCC concept with this application to the wind turbines. We call this publishing the applied energy first time, I think, in the 2017. So we tried also build the benchmark model for mimic the physical failures and also the cyber attack with publications. We still work on that. But currently, due to the lack of that hardware platform, hopefully we get a chance later on with the hardware platform. So we are doing this the simulation benchmark. So basically, treating the MATLAB simulation environment to mimic physical failures and a cyber attack in the framework of this microgrids, then try to develop different control strategies for achieving the safer, reliable, and also resilient unmanned system in general. So overall, that is just quickly give the works that we have done based on mainly the strong support from Quanser, all these different cutting-edge platform on the ground and on the air. So basically also testing the different strategies in terms of motion control and also imaging processing, particularly focus on that FTD, FTC, and FTCC works. Thank you all. Thank you all the audience for your interest in attending today's webinar. Thanks again for the great strong support, a long time of collaboration with Quanser, all the leaders and colleagues, and the supporting team from Quanser. Without this cutting-edge platform, we cannot achieve this stage until now. We covered all this very nice, very good platform, which even, like I mentioned at the beginning, we have so many publications. Because nowadays, the many journals asking for that experiment testing before really the paper can be published. Because the final goal, we try to provide the practical engineer solutions for all these works. Thank you again. Thanks very much.
Thank you, Professor Yuman. All I have to say is that you have a very, very busy research lab. and we're proud to play a small role, you know, in all the wonderful work that you've done. In the interest, if you have any questions, please have them come in. Although we are very, very short on time, so I'm going to get to 2 questions unless I see another one pop up. First question: what are the challenges for making good use of these unmanned systems that you've presented today?
Yeah, but normally, like in the previous slides also showed, we also try to develop some test bed from our own. But anyway, I think Quanser's development of all this mass cutting-edge platform, making our research easier, because all these things integrate together based on the strong team from Quanser. So in general, the advantage for this platform, because it is actually based on MATLAB Simulink, as we know that the platform, the software environment is relatively simpler. Even in the course I'm offering in Concordia, I mentioned just that flight control system course. I'm also teaching that modeling course. So then, you know, that course we introduced that MATLAB Simulink in the, yeah, I think it's one of the first course offering that MATLAB Simulink because of the simplicity. All this Quanser's platform making all these applications, use of this unmanned system that easier. But of course, still need to understand the configurations in terms of all this, the functions and the components available. Like a flight control for the flight control system course, the 6 labs students just try to understand the configurations and the components of this QBall, and also including the vision system, because we needed that vision system as a positioning, like an indoor GPS. So then try to understand all these components, the functions. But all this actually make us rather easier. Otherwise, if we develop our own, so it really takes time. Even so, we cannot reach to that desired state. So generally, it's really a good platform for the easy using or easy development, and particularly because it's open source. So we can implement whatever different strategies, like I mentioned, for FDD, FTC, and FTCC strategy. Of course, but probably we need to handle that real-time issues, but I mean, it is possible. So for the QDrone, of course, it will be more powerful, and the QCar also use the latest microcontrollers for onboard computer implementations. Or it's relatively simple, easy for making use of this platform, thanks to the Quanser's nice job. Yeah, thank you.
Thank you. And we'll just take one last question, Professor Zhang. What is your view on the future developments and applications of unmanned systems?
In general, as we know, so this unmanned system, it is one of the active research field. Not because it's a fancy platform, fancy things, but really linked to the real future applications. Towards we go from manual control, automatic control, then goes to what we call autonomous control. So even FDD, FTCC even go further. What if during the operation of these autonomous vehicles, autonomous vehicle system, then when the physical fault occurs, and with the cyber attack occur, we still want to make the system safe and use longer with different unfortunate physical failures and artificial cyber attacks. So in that sense, it is still a lot of work to do, but particularly for the different application, as I mentioned, for the first fire monitoring, like power line monitoring, search and rescues, and so many applications in the future. Even we also talk about the autonomous cars, even use the drones or UAVs, not only for the transportation of goods or the first fire monitoring, also carrying the passengers in the future. So all this actually could be for the real applications, the safety, security, I think from my point of view, is one of the necessary functions to be implemented for all this unmanned system. Otherwise, we cannot really, for the practical application, goes to commercial applications. So that's also, I thought, this challenge subject for doing more and practical research in my understanding. Yeah, thank you.
Well, this brings us to the end of our webinar. Once again, thank you, Professor Zhang, for your time and wonderful presentation. A big thank you to everyone who attended live today. I recommend that you visit our website at www.quanser.com to find out more about our numerous research validation platforms as well as our upcoming webinars. And please don't forget to follow us on LinkedIn and check out our collection of videos and tutorials on our YouTube channel. Have a wonderful day and stay safe, everyone.
Thank you all. Thank you, everyone. Bye-bye.